the identity sine squared theta equals 1 minus cosine theta over 2.
All right, cool. Good question. I like it. Okay. So I actually just had a discussion about this idea with my freak-out class this morning. Because this is something that goes through all of mathematics. It's understanding what a identity means and how to use it correctly. This room gets abuse. Alright, so we've got this. What's the conversion for this?
1 minus cosine theta over 2.
Do it again.
1 minus cosine theta over 2.
2 theta.
2 theta, my bad.
That's all right. Cool. So if you put a theta over 2 there, this would be a theta, that would be the half angle formula. So what I just said is actually what you're asking about. How does that change if I change this? What does that really say? That says whatever this theta is, I'm going to put twice that thing there, right? So if I had sine squared 2 theta, this would become
1 minus cosine 4 theta.
Yeah. So the 2 doesn't change.
Okay.
That's not what this says. It's important to know where this came from. And this came from, believe it or not, this came from, you can do it, Jeff. What's this? Who remembers what that is? Say again? No.
2
1 minus sine squared theta.
No, it's only
No, that is 2 sine theta cosine theta.
Yes.
This is 3 things. And the one I have memorized is
Cosine
this one.
squared minus sine squared.
Because then I can make the other ones as I need. So if I replace that with 1 minus sine squared, this is 1 minus 2 sine squared. Now watch, now go with me. I'm not going to write this. If I add this over, subtract it over, and divide by 2, that's where that formula comes from. It's kind of silly. This is not its own formula. It comes directly from this. It's kind of silly. So you really just have to know, all I have to know is this, which becomes that, which solves to be this. It's beautiful. Okay, right? That's kind of all of math quickly. If you think you gotta memorize that, and memorize that, and memorize, holy shit, you are quickly going to run out of room. Right? Your brain is going to go, no, you're about to forget how to breathe. I cannot overwrite that. Right? I remember that. I remember. All right, cool. So that 2 came from the fact that there's a 2 there.
All right, cool.
So just because that becomes a twice theta, that can't become something else. It's a 2. This is the rule. This says whatever that angle is, I put twice that angle there. So we saw the same thing when I asked my students in my freak-out, what's that? And of course, I kind of set them up for this. I told them, you're going to tell me the wrong answer, but it's okay. And a lot of them said 4 sine theta, and that's completely understandable. But that 2 comes from the fact that this is sine of theta plus theta, and there would be 2 terms in that, right? All right. So that would be 2 terms. That's why the 2's here. So if I had sine 4 theta, this should be
2 sine 2 theta.
exactly.
Cosine 2 theta.
Because whatever that is, I put half of it there, right? That's the rule. So that's why crazy people like me show you the derivation of things, because if you don't know the derivation, you don't know what the rule is. If I make that a 5, what changes? If you don't know the derivation, you don't know the parts that 2 won't change. It's because it's just a frickin' 2. It's this, the part that's dependent on what the angle is, that's the part's going to change. It's just like that 2. It's going to always be a 2. Right? Okay. All right. Was that? I can't remember the original question. That was all it was, right?
That was, yeah, I was just wondering how the 2 theta affected the derivation.
And then when you integrate, of course, you got to be careful with anti-chain rule or something.
Right.
When you integrate that bad boy, divide by 2. Yeah.
Can you do pi c?
Oh, everybody's 5C, I think some of you guys had like 5 and 12, and some of you guys had 4 and 3.
3 and negative 4.
Can't remember. Oh, there is the extra copies. Yeah. There they are. Okay, good. Yeah, so it doesn't really matter. Like that. So we'll do this one. But this one's actually too nice. We'll do this one. All right. So what quadrant is that in? That's the very first thing you should notice.
Third.
Both negative. The only place where they're both negative is third. Fourth quadrant, X is positive, right? All right, good. So you know that your answer better end up in that quadrant too. If it doesn't, you're wrong. Okay, cool. I like it. How do I find, and what am I trying to find on 5? I told you to go from rectangular to polar. How did I say it? Cartesian? Cartesian to polar. Cartesian to polar. Cool. I like it. So it starts in X, Y. So this is not R, this is not theta yet. That's where I'm trying to go. So a few of us treated this as if it was R and theta. That's not going to work.
R squared is equals 7 squared.
Yeah. So R squared equals X squared plus Y squared. Whatever the hell square that is.
Big number.
Let's just call it.
Nobody's going to help. 584? 576? Oh, so not close. Oh, sort of close. Got to end in a 6, Jeff. Oh, I was trying to estimate. And then this actually should come out to something nice. Believe it or not, if I work this out right. I don't know if I trust myself anymore. If you do this square root, it should come out nice. Is anybody going to do it?
Yeah.
Yes. Cool. So we know 3, 4, 5. Some of us know 5, 12, 13. Well, there's also 7, 24, 25. Right? There's a lot of those. And you know me, I can't let this go. Here's the squares, right?
Yeah.
You do it, Jeff. How far apart are these? I think we talked about this, haven't we? That's 3, 5, 7, 9. Interesting, right? So from, what's really cool is from 12 squared to 13 squared. If you know 12 squared is 144, like most of us do, what's 12 plus 13?
157.
What's 12 plus 13? Because watch this, what's 1 plus 4?
5.
And that's what you add to this to get to the next one. Right? Does that always work though? No, it's too bad. It's not what my point was. But this one happens to be, I can't remember now, I gotta remember how I remember the trick. This one happens to be if I add 25 to this, I'll get up to the next one. Right? I gotta remember what the trick is. It's not that, Jeff. I'll screw it. But these guys, these little triplets, 3, 4, 5, 5, 12, 13, they exist partially because of that truth. That all the squares are separated by consecutive odd integers. It's kind of neat. Anyway. So here we saw 25 and 24 are separated by, their squares are separated by the square of 7. That's really what's going on. All right. So what else do I need to complete this?
Theta.
Yeah, I need R and theta. So far I've got R. How do I get theta? What about tangent?
So it's equal inverse tangent of
There we go.
X over Y.
Inverse tangent of y over x. What quadrant would this be in? I'll give you the quick way to handle this problem. It'll be in the first quadrant, right? So if you tell me the answer is 25 inverse tangent of 24 over 7, or you put the decimal down there, you're not right. But the quick way to handle it is that. If I face the first quadrant but go backwards, I end up in the third quadrant. Now the other way to handle it is just to take this pi minus this, and then you're in the, or pi plus that, sorry, to get you in the third quadrant. So to sum up, your angle had better, or your point had better end up in the correct quadrant. You can either do that by walking backwards, or by adjusting your angle.
So I lost 1 point on that, but just because I didn't put the negative sign very well.
Something like that. Yeah, you didn't make sure that you ended up in the right
I
quadrant.
did do a decimal, and I thought that's why I lost the point.
No, I was okay with that.
Oh yeah.
Okay, what?
Just instead of doing it, I think you're telling me to reform, just put the reform on.
I'm not totally sure why, I mean, I don't know if you want to spend all the time on corrections for the test.
Oh, if nobody's asking any questions, then we're going to focus on what you're about to ask.
Valid. Question number 3, I'm not totally sure why I got it wrong.
Did you say valid?
I did. It was an affirmative.
I like that. Where are we at?
Number 3,
Yes.
for...
Oh, yeah. Okay. Everybody wants this question, so it's okay.
Oh
Everybody
Sure.
wants to ask this question.
Huh.
yeah.
It's a little...
Oh, I'm so like, I
I was
went
sad.
13,
I was
so.
sad. So,
I got it. Wrong.
that's right. You're one of the few that... Did you get it right?
Well, I asked you a question, yeah. I mean, I didn't get it right, I got maybe 4.
Oh, shit.
Yeah. Okay.
Let me ask you this. If I wanted you to find a specific point, I was going to give you a value for one of these two variables up there. Which one do you wish I would give you because it would make the problem easy? Do you understand what I'm saying?
Why?
Yeah, if I give you y, isn't it easy to get x?
Yeah.
If I give you x, that would kind of suck a little bit,
Right.
right? You'd have to kind of work it out. You guys see that?
Yeah.
Yeah.
So the easy, I asked for 2 parametric definitions. That doesn't mean, if you give me 2 x of t and y of t, that's one definition. Together they define a relationship. I need another one. So the easy one is almost always let one of the variables equal t. That's the trivial solution. Right? So if I let the one you just told me, if I let y equal t, what's x going to be?
X is going to be 3t minus
3t
2t
Minus
or plus 2t squared.
plus 2t squared.
plus.
Cube root, right? So I'm just solving for x there, right? So if there's a variable that you can solve for, do that first, and then make the other variable t. There's one possibility. And again, I see some of you guys looking, how do I solve this for x? You add this over, and then I take a cube root, right? So if y is t, x will be, throw a t in. What's another way to define it?
T x equals t to the cube root, so you can get 1.
No,
I just made y equal to e to the t.
kick ass. Y equals e to the t, y equals sine t, y equals natural y to t, y equals t to the t. Y equals, I don't care. Right? Now I could have asked you further, but I didn't really want to make this crazy. But remember, I could have asked you further about how does your choice affect your domain? Because remember, you can choose, we talked about this, you could choose a lot of ways to do it, but your choice might affect what part of the picture you get. If you use trig functions, you can only go up to 1 and down to -1 if you're not here. So you're not going to get the whole picture. You guys semi with me? So if I use y equals e to the t, then my y can't go negative. So I've lost any negative y value points from the original, whatever the original one was, right? So if this had any negative y's, I've lost them. But I didn't tell you to worry about that. I just said give me 2 possibilities. So y is e to the t, x is, throw in freaking e to the t, right? So that's all you had to do in that problem. That's it. Just notice which variable is easier to work with, and then work with it twice. Make it t, and then make it whatever you want to after that. Whatever you want to. It's wide open. Yes. T to the t to the t to the t. All right, maybe.
I'm still not totally sure why I got mine wrong. Can I ask you about it after class?
Sure. Okay. So that was number 3. Let's see, what else went freaky? Number 3 was universally unliked. Number 5 was, I don't know. When you're trying to convert from polar to Cartesian, what are you looking for?
Polar to Cartesian?
Yeah. So if it starts in polar, how do you get it to Cartesian? What are you looking for?
X and Y.
X, yeah.
See, that is if it's in, okay.
You're looking for your identities. R squared equals X
Yeah,
squared
good.
plus
So
Y.
you're looking for r cosine theta, because then you can know that's x. So if you see a cosine theta sitting somewhere alone, what are you going to do for the poor little dude?
Add R on both sides.
Yeah, like multiply both sides by r, right? Possibly, depending on where it is. So everybody had one that was like this, right? And there's no way I can just, here, I'll do both. I think everybody had that.
2 cosine. 2 cosecant squared. I mean, 2 cosecant.
Yeah. So everybody had one like that.
4 or 5.
4, yeah, like 4 and 5 together.
4A.
4b for some people.
Okay.
Let's see. So I know cosecant and secant, are they in any of my conversions? No, so screw it. Replace them with something that actually is in there, right? So what is cosecant? Now, one person on this did like give the top, bottom, and R, which is not a bad idea, but it's kind of overkill, right? What's the better way to get R to be with sine theta? Just multiply the sine theta up, and then it's with an R. Yeah, good. So a lot of you guys got to the right answer, but you went strange ways, but that's fine. Strange ways, completely acceptable. As long as everything's legal on the way. Right? Sounds like a book. Strange ways through life. Just try to stay legal. Now, going the other way. So normally that's a little bit easier. Oh, I'm sorry. Well, if you bring that up, what do you get? R sine theta equals 1. What's R sine theta? 1. See, as for SOHCAHTOA, it fails you so hard. SOHCAHTOA comes over there and says, I ain't got nothing for you. Sorry. But if you know that sine lacks frickin' y and cosine lacks frickin' x, you're completely fine there, right? I know, I'm going to keep harping on that. I wish they'd stop teaching SOHCAHTOA. I don't care how much you love it.
Oh, that's
They
right.
should never even have shown it to you. Then you wouldn't even know you're missing out on a pathetic thing anyway. Yeah, I know. I have strong feelings. Alright, so what about the other way? The other way normally should be the slightly harder way, but even then, what are you looking for? I'm looking for x squared plus y squared, because then I can replace that with r squared. I'm looking for x, because I can replace that with r cosine theta, same thing with y. I'm looking for y over x, because I can replace that with tangent theta. The big problem is, you know you're not done with the problem if I tell you to convert to polar and you still have an x or a y in there somewhere. Then you know you're not done. It's like u sub. If you still have an x in there, you should know you're not done, or something went wrong. Something is bad, right? So you know you're not done with a conversion problem until you've gotten all the way into the new coordinate system, right? Let's see. So everybody had something sort of like, there's no way to just do this completely.
3y minus y squared.
So I can do that, sure. So I understand a lot of you guys replace the x with r cosine theta, but isn't there a slightly better thing to do? You move the y squared over, right? Because then you'll get r squared. And what's y?
R sine x.
Yeah, and then you're almost done. If there's something simple to do, like divide an extra r out, you need to do it, right? You didn't have to, like some of you guys took 4a and you found the center and the radius. I didn't ask for it. I appreciated it. But you didn't have to do that. You could have stopped at the first step, really. And I just did it on the answer key because a lot of people were kind of doing it on that thing we were doing in class. So I figured I'll show you what that answer is. Okay. Is that cool for that? Or?
Can you just go a little bit further with the y over x, which was 5 feet for me?
Sure. So if I had
Make that tan theta,
5 minus y over x equals xy. I like it.
Okay.
So what can I replace with what?
5 minus tan theta.
Yeah, 5 minus tan theta. What's x?
X is a symbol.
No. What's x in terms of r and theta? R cosine theta.
Yes, R
Right.
cosine theta and R sine theta.
Right? So r squared cosine theta sine theta.
Okay.
And then you can divide by cosine theta sine theta, make it r squared equals that, blah, blah, blah. It's fine. There's really nothing...
And then you're really done. You kind of
You're
have
done,
polarization.
really. There's nothing there that's really substantial to do. In general, you don't take that square root and introduce a plus or minus unless you have to, like you're about to graph it or something, you've got to solve it. You don't do that. You don't introduce a plus minus unless you have to. But if you did, I'm not going to take points on it. It's fine. Yeah.
Well, I'm sure it's zero. What is it wrong with the saturation in 20? Is it negative in it?
It's not exactly.
I'm sorry?
Well, it's not, but I did it there here because I saw it on the ground.
You know how to do it, try to get points for it.
So guys, you know this. You know this. If I give you an angle like pi over 4, and you have to plug it in to get something, do you think I want to see decimals? If I was okay with seeing decimals, I would have said 1.2 radians. So what's the tangent of 1.2 radians? Good, that's the right answer. That's that. I have no freaking idea. So then you have to plug it in the calculator if I want to see something from you like decimals. But if I give you pi over 4, I picked that on purpose. I gotta, and this is what some of your Calc 1 teachers did not do for you, is to keep the trig alive in your brain. Yes, you can teach Calc 1 and have very little requirements of knowing what sine of pi over 3 is. But then you get to this class and you're like, shit, I forgot all that stuff. Well, yeah, of course you did. You haven't used it. So that's why I pick pi over 3, pi over 6, 5 pi over 6, 7 pi over 3, whatever, right? That's why I picked those. So if you see that angle, you know I'm going to want to see exact. Rad 3 over 2. I'm not going to want to see 0.7893. No. On the test or the practice one? The test. Number 2, they eliminate the parameter? Oh, yeah. All right. How do I do this?
I missed the same thing. I think it's past the 3. It's the next one. So it's 3y over 5. So what's 3y over 5?
Oh yeah, isn't it square?
Yeah. Do you do it?
Oh yeah.
Oh, boy.
You did this one. It is different.
That's what
I'm trying to make it not too much like something else. I won't jump. Just can't.
What?
Some answer
You
something.
can do it.
Huh?
Yeah, you can do
Is there something up there that doesn't have to be the way it is? I'm not sure how to say that otherwise.
Down.
Is there... Because what am I going to want to do
You
here?
can put the 3 on top of the T, basically.
And actually, it's the exact opposite of that. Because what do I want to do here?
Bring the button down.
Okay, good. Because what do I want to do here? How do I eliminate the parameter? That's this question.
You're going to raise it to
You solve for
All right, I'm going to try to solve for t. And actually, on the way to that, I could be smart. I could say, I need t. Why do I need t? Because I like t. Because there's a t there. But on the way to solving for t, I'm going to figure out what ln of t is. Do you see what I'm saying?
Okay.
So you can be smart about this. And I love giving that kind of problem to you where half of it is part, and then you go further and get the other half. So if I start to solve this, I got to divide by 3, right? So now I know ln of t is x over 3. So if this was just ln of t, that'd be awesome. But it's ln of t to the 5th.
You can press it.
Exactly. Well, thank God logs let me do that. So what goes here
X over 3.
That does.
Oh, so it's just
So what's t now?
it's just t squared.
Yeah.
What's t?
Oh,
Do it.
X over
What's the
3.
base?
X over 3.
Oh, what's t?
Oh gosh.
E to the.
X over 3.
And that's what goes in. So that goes there. That goes there. You didn't have to do that, but some of you guys solve for t and then plug it in. But then you got to simplify. Then you better, if you have an ln of e, hell yeah, you better simplify that.
Is there any
Oh, but. It depends on this three here. So I have to here. I have to put it up there.
I mean, watch this real quick. ln of 2 t. That looks really, really complicated, right? That looks complicated. Can I bring the t down? No. Is the inside being raised to the t power? No. It's twice that. But how do I handle a product? What's a log do to a product?
You can.
When do
add them. You can add them.
Yeah. Logs are powers. When I multiply things, I add the powers. So a product, a log of a product becomes the sum of the logs. What? These go away. What's this? And t divided by t? 1. I mean, so do you understand? Technically, this is the right answer. Do you understand why I would take points off? Because that is the right answer, but good God, it does not have to look like that. That actually, this is interesting. There's a whole thing about different forms of 1.
That sounds awful.
That is a form of 1. There's a lot, and we know like cosine squared plus sine squared is a form for 1. So if I had to put cosine squared plus sine squared somewhere, I totally could. I could multiply it by anything I want to because it is 1. And believe it or not, doing that sometimes makes my other work easier. So there's a whole like sub thing running through a lot of math courses where you think, oh, 1 is this, and if I put that there, this whole thing becomes easy. And I'm totally allowed to multiply any damn thing I want to by 1. Oh, thank God. How much do you have to understand that? What I just said for the final? Not at all. I just want to point it out. I mean, that's
That could be an extra question.
sure. Right? Now I'm thinking. You got me thinking. We'll see.
Plug in.
Make
Plug in
this
1.
So that this
Make
is
sure it's the right one.
Which one is the one?
it's a blue one. I needed the red. We can talk about the practice final too. I know I gave you the answer key, but it's there.
The answer key is very back on the package because
Right, today is the day, especially when nobody's asking questions, if something's never really made sense to you, now's the time to ask if nobody else is asking you.
I think that was number 2. Was that roughly 2? Or no?
That was roughly 2, yes.
Well, for mine, I marked that it turned into 1 and I lost a point for it. Is it because it turned into its exponent?
It should not have turned into 1.
Well, not the whole thing, but part of it.
Part of it, yeah.
Because I saw it for it like this, and then I put it back in, and now I have ln
Oh.
of 3's crossed out.
So it's not 1 to the x. ln e cancels and you're left with x, yeah.
Okay.
Yeah. Otherwise, that would just be 1. Yeah. Yeah. Oh.
It's just a question about the logs and natural logs.
That'll come to you.
I had ln, parentheses of fraction, with x over 3. Is there a way to simplify that?
You could rewrite it as ln of x minus ln of 3, but that doesn't really help you. Yeah. I mean, like here, rewriting this is this the sum helped me because then it canceled, but rewriting that wouldn't help you at all.
is there a formula to get the tangent lines of on a polar equation, or
Totally.
we have to change it to?
Isn't it on there?
It's on the bonus question of the last
Here, it's on the Study guide right there. No, it's not. Where is it? I thought I put it on here.
Oh, on a folder, I think you did it.
Shoot. No, I didn't.
He's in it, the D, double prime.
So, remember,
D.
so if I want to find dy dx for polar, you parametricize the polar. So if I'm given r equals a function of theta, you say x is f of theta, cosine theta. You say y is f of theta, sine theta. And how do I do dy dx? Well, that's not t, sorry, it's thetas now. So that's kind of like my parameter now, right?
dy would be theta over here.
So dy d theta over dx d theta. It's not.
So basically you change it to Cartesian. Just that.
Oh no, this is parametric.
Well, to parametric, my bad.
Yeah, yeah. And then this is where that whole thing comes from. This is really r here. So dy d theta would be dr d theta sine theta plus r cosine. So I'm just applying the what to this? Dy d theta, so I have to do the what are r and sine doing? What are r and sine doing to each other?
Multiply?
Yes, so then when I want to take the derivative, I have to apply the
Chain rule?
product rule, because it's a product, because it's multiplying. So I did derivative of the first, leave the second, plus leave the first, derivative of the second. That's all I did,
okay.
right? That's all I did. And then on the bottom, incredibly enough, do it again for x, right? And that's where that formula comes from. But I don't think I told you you had to memorize that. So if I give you, I think there's a bonus problem on the test. So for bonus, I can do whatever the hell I want you to. But on the actual test, if I give you a problem like this, I will give you the equation. But this is how to derive the equation.
And then well, I thought that for the tangent line, probably my bad. For the tangent line, it was a double derivative of d squared y over dx.
Yes. I'm not going to focus on the second derivative though. But
That's defined as tangent line, isn't it?
no, that's define the concavity. Tangent line, you just need the slope, which is the first derivative. Number 7 on the practice fund uses this. Uses what? What we just talked about. So it should have that formula. Yay! On the back of the entry key, number 7 uses this.
How?
Directly.
Finding the area.
No, number 7 on the back practice fund.
Test.
Yeah.
Practice final, I'm sorry.
Yeah.
My bad.
That's all right. Yes, sir. Oh, did you have a question?
Yeah.
I'm sorry, real quick. Yeah.
Go for it. For number 4, still.
On the test?
Yeah.
Yeah.
Mine was 3 cosine theta minus 2 sine theta. Do we have to multiply by r?
Yes. Because are you looking for r? No, you're looking for r squared. Are you looking for cosine? No, you're looking for r cosine. You're looking for sine? No, you're looking for r sine. So everybody in that equation needs an r. So then that's beautiful. What sucks is if different parts of the equation, I need 2 r's. I don't need any r's. That would suck. Right? And then what you do there is you just kind of give the most r's anybody needs and then work with the other stuff. Is really what you do. So in my pre-calc class, just to warn you, you could very easily have this on yours too. We had a problem that was like this. What was it like, Jeff? I don't know, something like this. Sure. This is not even a bad situation. It just needs you to remember to realize something. How many of those things needs something?
1. 2.
Getting close.
3. What?
All 3. Because what is x squared? What is x squared?
R squared cosine squared?
Yeah. R squared cosine squared. So has this got everything he needs? No, it needs one more r. this got everything he needs?
Nope, needs another R.
Needs another R.
R.
So again, this is a beautiful situation. If everybody needs the exact same thing, you go, oh good, I can do that. I'll give everybody an R, right? Jesus R, pick his function. There's only one R, Jesus. Well, that's okay. I'm the least religious guy in the world, but I love that idea. What's up?
You never know.
I don't want to get into maybe about religion. All right. Is that cool? And then what would happen here? This would be r squared plus 3r squared cosine squared equals r sine. What do you get? X squared plus y squared plus 3x squared equals 1. What is that the graph? If I graphed it, what would it look like?
It's gonna be like
Ellipse. Why ellipse? Because it's not x squared plus y squared, it's 4x squared plus y squared. You can subtract the y, you can complete the square, get the center, get the radius, blah, blah. It's not going to be radius because it's going to be ellipse. Cool.
So,
Foci.
is that the final answer?
This would be fine. I mean, well, get your like terms together. If you stop here, that's fine. If you subtract the y and complete the square and all that kind of stuff, that's awesome. If I don't ask for it, though, you don't have to do it.
But you'll give us
what would you ask for it at the time?
I like that.
I did anyways in the test, just hoping that you might.
Oh, I see now. You just gave me more stuff to look at, so
Yeah, basically.
I was going to take some points off. Oh my God! I didn't ask for that. I'll see that. Check. Don't try. I appreciate it, though. That's a good thing to know how to do. All right. Yeah.
Can I show you?
No. I see. Wait a minute. No, I don't see. You're here. Where did this come from? I don't understand. R squared is... Oh, no. All right. So, from the very beginning... All right, let me see. I think there's a little bit... I don't know how to explain this, but... This is, if I had this here, one way to make this r squared is to square both sides. Do I want to do that? And you're like, we don't know, Jeff. You want to do weird shit. You like this stuff. I don't want to do that. Why not?
Why don't you want to do what?
Well, he needs to be an r squared, so I can make an x squared. What do they need to be? R sine theta, R cosine theta.
Yeah.
If I square both sides, I'm going to FOIL this out. They're still not going to have any R's. And in fact, parts of them are going to need more R's. Shit. So instead of choosing the route of squaring both sides to make this R squared, I'm going to choose the route of multiplying both sides by R to make him R squared. Which means I totally forego the option of squaring both sides. Right? So if I multiply both sides by R, that is y. That is, and I'm basically done. That's where you can stop for me. Now that would be the equation of a circle because the coefficients are the same. So it's symmetric in both x and y direction. Right? That makes sense. If the ellipse has a different number in front of it, it's x squared instead of y squared. That's why it's an ellipse, because it's differently shaped in one direction versus the other. Different length. Is that cool? So you can totally stop there. If all I ask you to do is take polar and make it Cartesian or rectangular, whichever one I choose to say at that time, there, you did it. You did it. There's nothing that, there's no like terms. You can stop. If I said, find the center and the radius, or find the important parts, find the center of the ellipse or whatever, then you'd have to complete the square stuff. Cool. Which is not a skill I necessarily feel like testing you on, because that's something you should be able to do anyway. Yeah.
Can you explain where the dr with d theta number 7 on the practice of this?
it was the stuff I had up here earlier. So if x is r cosine theta, and y is r sine theta, right? You with me? No.
Well, I mean, I get that, but
That's that.
how is that related to this? On
What's-
the practice exam,
Yeah, what's 7 asking for?
find the slope of the tangent line to r equals cosine.
Cool.
Okay.
So then I have to figure out,
dx, dy dx.
yeah, I need to figure out the slope, dy dx.
Okay.
So take derivatives of both those.
Yeah, so what I'm saying is, this is a procedure that they spelled out in, I can't remember which section it was, where
I think it's 10-4.
something you do in Calc 3, and that we haven't done directly. I mean, some of you guys might be asking, well, how do you just do this by itself? Which really involves, how do I look at slope in a different coordinate system? Do you understand how that's a higher level idea?
Sure.
Not even something that I don't think you can handle, but just something that we haven't talked about. So how in the world can we suddenly know how to do that? So what I try to do instead is to take this back into something I understand, which is parametricize this. Right?
Parametricize.
Yes,
All right.
that's the new
verb.
fitness craze going across the... I don't know.
Let's make it a hashtag.
So if you do this, if you're given some R, whatever it is, so it's this here right for us, then what I do is I put that here and here to force this into parametric. Yeah, so this is not something you do in general. Some of you guys feel like the way you convert to rectangular is to do this. But you see, this doesn't end up in rectangular, this ends up in parametric, right? Are you guys with me? Because a few of you guys did this when I said convert to rectangular, convert to Cartesian, you threw R in here. No, that's converting to parametric. No, just convert to Cartesian, right? Which is when we do stuff like, if I see an R squared, or replace it with x squared plus y squared. I mean, that's direct conversion, right? This is a process to get around the fact that we actually don't even know how calculus really works completely in the polar coordinate system. We really don't. I'm sorry to tell you. And why should we? How long have we been talking about polar? Not very long. In the last chapter that we just did, right?
Right. I thought you meant, when you said we, I thought you meant like as a math community.
Oh
the
shit!
world.
No.
I was like,
not
wait a
as
second,
not
what?
as a race. Human race. How long? It should be in your genes. Come on.
Have you worked?
Oh, no, I know.
Have you personally worked with polar graphing or polar calculus?
Of course, you start to do it in Calc 3.
That sounds not fun.
Yeah.
Oh,
not
it's so
fun at
awesome.
But you say things are awesome and they're not.
That's true. They are. It's a lot of fun.
Fun.
We all have our own things we like.
Please
All right.
define fun.
So is that?
No, that makes sense.
All right.
Yeah.
So now if we can't handle that directly.
Right.
So we only understand slope in terms of y and x. So when I say that, I'm referring to that process. But you're right. I like your feeling that there's got to be something more to it. I should be able to just attack it directly, but we don't know yet how to do that. I wish I would have brought this. So you know how when you integrate, it's dx here? So if I change coordinate systems, it's not going to, if I change to,
D theta? Well, no.
see, it won't be. We have a very specific situation of finding the sector area. I just put a d theta there without really thinking about it, but there's a lot more to it. So part of what you talk about in Calc 3, for example, one thing you talk about is triple integration.
Okay,
So if you have a sphere, you can integrate
So it will be d theta d.
over the whole thing. Huh?
On polar will be d
So
theta,
you'll
d r.
talk about what these become based on which coordinate system you're in, which is something that we don't touch here, but we do introduce the idea of calculus in these other coordinate systems. We just don't really get into it fully, because there's not a time. All right. So if you're not taking Calc 3, I'm sorry. You won't be able to enjoy that.
And I'm sorry.
I had a feeling you might be there.
Anyway,
Just wait till you get there.
I know. I heard it's like, it's completely different than Calc 2.
Yes.
It's a whole different.
Yes. So if you really didn't like Calc 2, for some reason,
It's whatever.
then Calc 3 is at least different.
I heard it's easier too.
Normally, yes. Believe it or not. Not based on what I just made it sound like, but the worst thing in Calc 3 is if you want to change these around, and you have to change limits around. But when you put something inside of another integral, the limits don't have to just change, they actually have to be converted from one variable to that's the process that gets students down. Especially when you're doing that in a different coordinate system that you're just getting used to. That's the worst part, I think. That's the worst part. You have to take out 3, you get there, you go, oh yeah, that's what Jeff said. But it is true, most students like Calc 3 better than Calc 2. Which is fine by me, as long as something is liked in some way. You got all kinds of time. Yes?
Can we refresh on 1B, the final?
Oh. So, you can see what I did, and I can tell you what to do, but your question really is, how do I know when to do that?
Yeah.
Okay. So, real quick, so we are going to talk about 1B on the practice final, on the poof. But if I gave you this problem here, oh yeah. Does anybody have an idea what to do there?
What is this? This is practice final?
Sort of. It's not really.
Yeah.
It's not on it.
Yeah, you can do long division. I like it.
Yeah.
So that would be a long division problem. I wouldn't have to. I couldn't do partial fractions because I can't even really factor. I can factor that using complex numbers, but I really don't feel like it.
Use trig?
I like it. You could use trig sub, and if I
It'd be
did
tangent.
this, you would probably
Right.
want to use trig sub, right? So through your tears, you would figure that out. So this problem, I want to. So the real good question is, all right, I see what you did, or I kind of see, but how do you know when to do that? The main reason I knew why to do this is because the bottom is factorable. The bottom is nothing nice. In fact, I certainly don't want to use trig sub here because
You have a cube.
I have a cube, and none of my identities have cubes, right? Now I could take an x out and maybe use a trig sub, but look at the top. I mean, that's just not gonna work well. So trig sub problems have a certain look to them.
That's not a constant. But you also don't have a constant at the bottom.
Don't have a constant? How do you mean?
Well,
Oh, take an x out, though.
yeah.
So I mean, technically, if I had this on the bottom, I could use trig sub. You guys understand? Because what would I let x equal in this case? If I want to use trig sub on this?
Tangent, theta.
Yeah, because tangent squared plus 1 is secant squared. So I would just put a tangent theta there. I'll put a tangent theta there. Right? And my dx, I'd have to make it
Secant squared theta.
secant squared d theta. I like it because if x is tangent theta, dx is secant squared.
Theta tangent.
And whatever's on the top, blah, blah, blah. So trig sub wouldn't not work in something with this bottom, but the top is just not looking like it's a trig sub.
That's just gross.
It could possibly still work, but I don't want to do that. So when I see something like this, where I have a nice big polynomial there and I've got a factorable bottom, then I'm thinking partial fractions. I mean, that's what needs to come to mind. That looks like a partial fractions problem. It doesn't mean it's the only way. It doesn't mean it's the easiest way. But it means that's the thing to try. Right? So, do we remember how to do partial fractions?
Yes.
Yes.
Break up the bottom. And then equate the
It's going to be a over x plus b x over x squared plus 1.
bx plus c.
Oh, yeah, bx. close.
This bottom is truly second degree. It's not just a repeat. If it was x plus 1 squared, I would have ABC over x plus 1 squared. Right? This is truly second degree, so the top has to be the most general first degree.
We'll have D and E too, right? Bx plus C.
No.
Plus
So again, if the bottom was this, I'd have a over x plus b over x plus 1 plus c over x plus 1 squared.
You wouldn't have bx plus c over. Oh no, because it's not. Okay.
It's not truly
Right.
second degree. It's the repeated first degree. Which don't get me wrong. This is not all of a sudden not second degree. That x plus 1 squared is completely second degree. But in the eyes of partial fractions, that is a repeated first degree.
Got it.
That's why the top is not first degree. It's got to be 1 degree less. It's got to be a constant.
Right.
And then you multiply by the LCD, right? So what's he pick up?
Ax squared plus 1, and then bx plus c times x.
Cool. And then you can do whatever way you want to. You could multiply things out, put your electrons together, equate coefficients, or you could let x be something. That's what I always start with if I can. I always do that as much as I can.
Do what as much as you can?
What would I let x equal to kill some of this? 0. That's the only thing I could let it equal to kill some of this, right?
Yeah.
I could let I could make it equal I. I could.
I wouldn't.
Do you want to?
No.
No, but you could. So if I let x equals 0, what do I get?
4 equals a.
4. Awesome. Equals?
A.
A. Hey!
That was hard.
That's awesome. Now, here's the trick. If you can relate, how do I say this? I could get B directly, but C is going to be interesting. C will actually be easy. C I can get right now.
goes forward.
Can you?
A has an x squared and a 1, right?
C is the only one.
B has an x squared. C is the only one that's an x, so I know C's got to be 1. Okay, so let me multiply this up. So you get ax, and this is a 4. So here's what I would do. You ready? Well, let me show you fully what I would do. You ready? Well, actually, what I would do is exactly what it just did. I would just say 1 is C. I just know 1 is C.
Yeah.
Because C is the only thing that has an x on it. A has an x squared and a 1. B has an x squared. C's the only thing with an x, so C's got to be 1. Right? So let me show you a different way than what I do. One thing you can do is put a 4 here and then subtract this terms over. You guys see that? I think I told you that.
I'm sorry, do that again?
So you could, I know A is 4.
Right.
So I can put a 4 here. So there's 4x squared, I can subtract it over.
Okay.
So I get negative x squared. There's a 4, subtract it over. That 4 is gone. And now I have this. Let me let that soak in. I know A is 4. Put it in. So 4x squared, subtract that, bam. 4, subtract that, bam. Why is it nice that that guy died? Because I don't have any constant terms here. If there was a constant term left there, okay. I have done something. Yeah, so B equals negative 1. C equals 1. It's crazy. So that's not the only way to do this.
There's not enough. Would give my matrix and something.
You could. I mean, right from the beginning, you could have said ax squared plus bx squared equals 3x squared. Cx equals 1x. And b, that's it, right? And a equals 4.
Then you plug in 4 for A in the first equation.
Yeah, so that actually came out pretty nice.
Solve for B.
But most of the time, doing this will really cut through some of the work. This one, it just turned out to be nice. So you have a few different ways to do that.
Can we use a calculator to do that?
What do you think? You can ask me that question. Go. technically, in the real world, if you were not being graded on it, you could totally set up a matrix, put it in the matrix, do RREF, and the transfer. Totally.
What is RREF?
Row reduced echelon form. So it's
That sounds.
1 0 0 0 1 0 0 0 1, and then answers are just lined up at the end. Right? That's reducing matrices.
I don't know what that
You never done that? Chris is like, stop. Final, leave me alone. That's completely right attitude. I like that. That's good. It sucks that you've never done matrices, but you know.
I mean, I did like matrices in like algebra 2, but it was very basic stuff.
So whoever your pre-calc teacher was, you didn't do it.
Yeah. Pre-calc was high school. I took pre-calc and calculus.
Well, that's what I'm saying.
Yeah.
You can still do it in pre-calc, whatever level you're at.
Okay.
You don't have to take pre-calc to take Trig and algebra.
Well, no. Do you understand 176 equals 170 plus 175?
Yeah, no, but I
There you
took
go.
176 and those other two classes, and it's not the same thing.
Okay.
Pre-calc goes further, and you don't went this far in the algebra or the trig.
All right.
I took all 3 classes.
Good Lord.
Can you do, I'm sorry to interrupt,
That's
4A
fine.
on the practice final exam or something similar?
All right. So this is the whole idea, like the. I gave you that last problem on the test before this.
Yeah.
We had to use a known power series. So I give you. Oh, I keep forgetting. I want to go back to that bonus question I had on the board, because that's related to the shirt that nobody seems interested in. I don't think we ever actually proved that.
No, we did. I just
Oh, you
forgot.
did?
Yeah. I just forgot.
I forgot too.
No, yeah,
I
we
just
did.
forgot to do it.
For Oilers, right? You said.
Oh, we did. Okay.
Yeah.
I thought we did.
No, you forgot. We did it.
I totally forgot. All right. So if I know e to the x, so I give this to you.
That, are you trying to say that's going to be a bonus question?
What's up?
Are you trying to say Oilers is going to be a bonus question?
Oilers, identity, anything could be bonus. I'm not going to give you any insight. So what would this be?
Just put in x, or negative 1/2 x squared, where x is.
That's insane.
It's like too simple.
I want you to understand. We now understand that this could be the definition of a function. So if I had f of x equals 3x minus 7, what is f of e to the 2x minus 3? What would you do?
Just plug in.
You plug that in place of x. Isn't that exactly the same damn thing we are doing at the moment, right? So if f of x is e to the x, this is f of negative 1/2 x squared. So what am I replacing x with?
All that.
Negative 1/2 x squared, right?
So do you want us to take it out to simple terms, or just leave it in the
No. So here's what you got to do. That is not good.
Okay.
You need to simplify that, right? So what can I do? I can raise everything in
2n.
So I have negative 1 to the nth power, right? Everything is raised to the nth power. You with me?
Yeah.
2 to the nth, I can put that where?
Bottom.
I'll tell you where you can put it, Jim. All right. Be nice. And this will be x to the
2n.
2n. Real quick, too. That.
Yes.
That would be like, so are equal 5 factorial? Couldn't I say that's 1 times 2 times 3 times 4 times 5?
Sure.
So 2n factorial would be 2 times 4 times 6 times 8, which is 2 times 1 times 2 times 2 times 2 times 3. What's my point? This equals that. Well, that's kind of an interesting thing to know. N factorial would be 1 times 2 times 3 up to n, right?
Sure.
What would 2 to the n times n factorial be? Each one of these would get a 2, because there's n 2's. So wouldn't that be 2 times 4 times 6 times 2n, which is 2n factorial? So I actually use that fact on the answer key on number...
Wait, how?
I use that on number 3 to check the endpoints. That fact. Just to let you know, in case you're looking at that, like, what happened?
But you know you get Because if you plugged in, say, 2 for n, you get 2 factorial times 4.
So what's, so say again?
Okay, yeah, it makes sense now. Sorry. I just had to do it. I just had to.
You don't have to know all that for this, by the way. This one is not dependent on that. You with me? So what can I do? Now that's basically done. Is there anything else I can do there?
I mean, you
Nothing
could
really.
do 2n factorial instead of 2 to the n.
Yeah, I could, but we won't. It's better to have them separate anyway, to be honest. All right, so what was the next thing I had to do? Now I got to integrate this thing, right, for part B. Part B. And the interesting thing is, if you've taken any statistics, do you notice how this is different from the question I had down there? You with me?
Yeah.
Integrated A, this. This is the area under a normal curve from this z-score to that z-score. Right? Actually, it doesn't have to be negative A, it could be whatever. It could be A to B. Doesn't matter. So, anybody taking statistics? Do you remember empirical rule? How much is within 1 standard deviation? There is within 2 there's 95%, within 3 there's 99.7%, within 1 there's 68. So if I integrate from -1 to 1, I should get that, but I made it from 0 to 1 and then doubled it because it's symmetric. Right? So that's where this came from. It wasn't just totally out of my ass here and then divide by square root. What the hell is he doing? This is an actual real formula for the normal curve. And then you just put that in here and integrate it. And I think I put the terms, didn't I? I can't remember which way I did this.
In 4a?
Yeah, I integrated the terms. So I wrote some terms out and integrated by term because then it's just a polynomial. It kicks ass. Is that cool? So when I want to integrate this, I can just put some of the terms of this. I let n equal 0, n equal 1, n equal 2, and then I just integrate it by term. Right? You guys are sort of turned on now. What would I put in here? N equals 0, what do I get? Yeah, you get 1, right? You get 1 times 1 divided by 1 times 1. N equals 1. I'll get negative
x squared.
Good. Negative x squared over
2.
And so forth. Now you get the stuff that I put in there. Let's just go for it. Plus x to the 4th over a minus.
So that's going to be
X to the 6th over 48.
4a.
Maybe. And then you just integrate that. It's awesome. You let that integral be easy.
4a right here.
It's just a polynomial.
So when you say within 1, that's just within 0.001, that's how many decimal places you want us to take it to?
I'm sorry?
4b, you say evaluate it to within 0.001. So you
Yeah. So what I did was
compare it to our calculator?
I went one more step out, because I kind of knew I had to stop here, but I went one more step out just to check. And I saw that didn't, I want to go to 4 decimal places, and that extra piece didn't make that different.
Okay.
Remember, that's how you tell where to stop, is you go one more step, and if it doesn't change out to that decimal place, you can stop there. We've seen that before. So if you've taken stats and you saw this, you should know this is not integrable. This is not an elementary function. This is not integrable. So you have to use a infinite series to do it correctly, and you can stop if you want an approximation. That's how computers and stuff can do it quickly. It's because they just go out several places in the polynomial, and then for humans it looks exact. Right? You go out 28 places. I've lost interest by that before that. So looks good to me, computer. Yes.
Did you do the
5% extra credit for the last test.
Because we had
Yeah,
to
you said
cut
you
Thursday
can
short.
5% of that and add it to
Yes,
the
totally did. That's factored in. So I took 5% off the last test and I added it back onto your highest test. Your highest test grade might have been the last test, so it just went right back on. Is that all right? I mean, that's
Didn't get
in your average. The way your test average was calculated was I averaged all 4 tests,
Okay.
then I subtracted 5% of test 4, and then I added 5% to the maximum of the 4 tests.
5% of the week.
Of the weight.
Yeah, not the actual score.
No, of the score, yeah.
So it's already included.
Yes, it's in your average.
Okay, cool.
Yeah.
Did you already run over number 6 on the test?
Do it. Say again?
Did you already go over number 6 on the test?
I'm on the test.
Because you said to show work, I'm going to plot it, but I don't know how to plot it.
Yeah, me too. Yeah.
So the thing with this is once you get one leaf, so half of you guys had one that looked like, let's see if I can do this. Half of you guys had one that looked like, I can almost do this, yeah, like that, and the other half of you guys had one that was like offset like this. That's almost it, yeah, there you go.
Symmetric.
I forget which way to turn as you come to the origin, but oh. So I wanted you to find points. You have to show me, some of you guys did not enough points. So some of your leaves, I mean, this is obviously nowhere near enough points because it's no points. And that's why this leaf looks very different from that leaf, right? So if you have a big-ass fat leaf and over here you got this little skinny leaf, that's no good. I mean, once you determine, but the nice thing is you don't have to make a table all the way from 0 to 2 pi. You determine at pi over 3, it's at that. So at every pi over 3, it's going to be at that. That's the pattern that you start to see develop. And the less you see the pattern, the more points you got to do on your table. That's the trade-off, right? The more you understand, the less you got to do. But so I need to either see the table and then you plot those points, or at the very least, I need to see some of these labeled, and then the other ones better be in the right place too. So if I didn't see any table and I just saw this that could have easily been copied out of the calculator, that's not good enough. Some of you guys realize that I've shown you how to use a table in your calculator, and you guys should just copy the shit from your table and calculator, of course. Alright. Nothing wrong with that, but the thing I want you to at least do is I needed to make sure that you can plot polar points without making a whole separate plot these polar points problem. Well, ease in that sense.
I have another question about 7. I got I was doing the test corrections, and I got to the integral of 1 minus cosine 4 theta over 2. Why can't you just pull that 1/2 out?
What's the matter? Yeah, you can totally pull a 1/2 out.
But then the answer is 0. I get the answer is 0.
And what were your limits?
0 to pi halves.
That's fine. I think you treated the sine squared or whatever
Right,
wrong.
but on the test corrections, I redid it, and I get to this, and then you pull this 1/2 out.
Oh, and what are you left with inside?
Right? Negative cosine.
No. How many terms are there on top?
2.
So if you pull out a constant, you better be left with two terms still.
Oh, so you have to leave a 1.
So if you pull an over 2 out, you're left with the top. 1 minus cosine 4 theta.
Okay.
I agree that cosine 4 theta part's going to go to 0 when you integrate it.
Because I broke them up into 2 terms, 1/2 minus.
Beautiful. But if you factor a 1/2 out, you can't suddenly lose a term. The only way to lose a term is to subtract.
Because if you factor out the 1/2 becomes 1.
Beautiful. There you go.
That's what you're saying. Right. Okay.
Details, man. Weird little details. details.
I'll mention this last one.
For next week, are you gonna be in your office or office hours?
You've got my schedule.
Okay.
Yeah. Because next week is completely. So I'll be
Are you
grading.
I didn't look at it actually.
What's up?
I haven't looked at your office hours for next week. Are you gonna be there by any chance?
You got it on the grade sheet.
Okay.
Yeah, I will be there.
Okay, good. That's fine.
And you know when. Yes.
Can you explain like the different ways for the interval to get paid
For which one?
Number 3.
All right, so I'll admit this. Number 3, if I gave you that one, I would say checking endpoints is extra credit because it was a weird one. Right, so I focused more on making an interesting series problem, and I didn't think ahead to what the endpoint problem would look like, and it was really weird. Right? In fact, the more I think about it, the less I am convinced that I'm right over there. Because that's a weird thing, and that's the only thing I can think of to do. To be honest, I made the problem without thinking about what the endpoints would look like. And you end up with a weird, difficult to handle thing.
For which one?
Number 3. Yeah. So either, if I don't say endpoints are extra credit, they should be completely doable.
Or to test the endpoints?
Yes. So it's always a part of it. But if I make a series where the endpoints actually are weird, I might say that it's extra credit to check the endpoints. You can tell me the radius, and you just don't know if it converges at the endpoints. That's fine. If I say it's extra credit. If I don't say it's extra credit, you got to do it. It's part of the problem.
Since there's a bulb, I showed you the number 3. So I kind of understand what you're doing before, but I just don't understand why.
Oh, well, the problem is, I sort of see what you're trying to do now. You need x equals and y equals. No, you don't. Show me where you say y equals a function of t. Point that out to me. See, so you chose the wrong variable to let equal t. You want the y piece to equal a function of t. Because then you can solve for x easy. What's up?
One is going to make us put it in decimal.
Yeah.
I made it. Double check. I'm not sure, but
Come on,
I
Jeff.
Why are you asking me?
Next one. Next
Come
one.
on, Jeff.
Why ask me a question? It's a -1. So yes, you lost 1
Right,
point.
no.
I don't know how
He
to
made
clarify.
it really late. He thought he had it due for his airplane, but
Total.
Yeah, because I feel like
That's it. There's nowhere else to go.
I'm gonna go home and do this. No, I haven't thought it.
What's why we're at that?
I forgot about that. Well, it's because I just made,
Yeah. So that's how you just data equal
more credits, but
4 minus and what's
they're
that?
studying themselves, so I just figured out how to.
That's all I gotta do.
That's kind of what I did.
All the x's and y pieces
like right there, but I
we're done. Unless there's some easy simplification.
Yeah,
I'm kind of stuck. I'm having a.
Do we want a double pulp? Do we want double pulp?
So take that 1/2 and make that 0.
Right by the.
And then you can integrate 1.
Oh,
And
I know
integrate
where that
Yeah,
is. Is that where Mr. Ivan finds it?
they weren't that hard.
Are you going to stay test corrections?
I just did done.
Here, go home.
I mean, I'm gonna go to the Mass Study Center and probably work on the
You leave the
practice.
8 outside.
What you said for the
And
final?
then you just integrate, just integrate 1.
Yes.
That's 8 out.
I'm just gonna
Well,
run
yeah, my
the.
friend yesterday,
I ran the student or the.
and she said she got home and text at like 4 a.m.
Your phone.
I know. She's like, I got like 6 of your messages super late.
Yesterday, I don't know what time, when I got a message from you. I was like,
From who?
Almost
no,
done.
it can't be from you.
Oh.
And you answered the question from 2 days ago.
Oh,
And I
yeah.
was like, okay.
No, the whole thing. There's only that.
Oh, no,
part.
see.
Oh, so this one.
No, dude.
Yep, cool.
Dude,
And then
65.
I get an 8 in front of all that. And then you
And that sickness fucked me up, dude, because I already did all the corrections. It was,
Thank you.
Oh, you just did it?
yeah. It was an easy fucking test. I don't know what I was thinking.